For natural numbers x, y, and z, if xy plus yz equal to 19 and yz plus xz equal to 51, then the minimum possible value of xyz is. Okay. Now, if you see the first equation, we can take y common from the left hand side. So y into x plus z is equal to 19. Okay. Now 19 is a prime number and therefore there are only two possibilities. Either y is equal to 1 and x plus z is equal to 19, or y is equal to 19 and x plus z is equal to 1. Okay. Now it is given to us that x, y, and z are natural numbers. Now the minimum natural number is 1, and therefore even if we take x and z as 1, 1, it will be 2. But here it is, we are getting x plus z equal to 1. And therefore this case is not possible. And therefore we get the value for y, that is 1. So now we have y is equal to 1 and x plus z is equal to 19. Now let's take the second equation. Yz plus xz is equal to 51. Now from here we can take z common and it will become y plus x is equal to 51. Now the factors of 51 are 1 into 51. Okay. So in that case, z will be equal to 1 and y plus x is equal to 51. Okay. Now from this, we can say that x and z should be less than 19 for sure. Right? Now y is equal to 1. So over here we get x is equal to 50, which is not possible, and therefore this case gets eliminated. Okay. So in this case we assumed z equal to 1 and this bracket is 51, out of which y is 1 and therefore x becomes 50. But as per this data, x and z should be less than 19 and therefore we have eliminated this scenario. Next case, z is equal to 3 and y plus x is equal to 17. Okay. Now y is 1, therefore x comes out as 16. Okay. Now it is satisfying this criteria and therefore this is a possible scenario. Okay. Next scene. Okay. Z is equal to 17 and y plus x is equal to 3. Now y is 1, therefore x is equal to 2. Now this is also satisfying that x and z are less than 19 and therefore this is also a possible scenario. Okay. Now the last scenario, z is equal to 51 and y plus x is equal to 1. Now we have seen here as well that x, y, z are natural numbers and y plus x minimum value will be 2. And therefore this case is not possible directly. Okay. So there are only two cases possible here and we want the minimum possible value of x, y, and z. Okay. So let's take the first scenario. I'll write down the individual values of x. So x is 16, y is 1 and z is 3. Okay. So x, y, z comes out to be 16 3s are 48. Now the second scenario is over here. X is equal to 2, y is equal to 1 and Z is equal to 17. And therefore the product XYZ comes out to be 17 to the 34. Now out of these two values, 48 and 34, the minimum value is 34, and therefore that will be our answer. So the answer for this question is 34.